Hi everyone, welcome back to another Sean's tutorial. This tutorial we will try to analyze wind to use Simscale as the web-based application. You can import your 3D models to analyze the wind velocity, also the wind pressure, wind speed as well. So that's some result I have been done on previous projects. So let's begin to set up the new one. So I will just draw a simple geometry to represent as the building, maybe a bit too big, smaller, yes, and also has some geometry over it to see the wind, how they behave. So maybe put it as a ghost. So that is the whole environment, and then my building is a sit in the middle. Just remember we need to have really high head space for that, so it can be more accurate because the wind accelerates on top a lot, and you may don't want to miss it if the box doesn't capture the space. The outside of that won't be simulated. So let's reference that as a graph. Reference the box first, and then we set another graph as the whole, representing the whole area, the air. So what we need to do is we need to subtracting between those geometries, use solid difference. So use A, B. Let's don't preview it yet. Let's see how it looks. Subtraction. Nope, that wasn't what we want to see. Maybe just like change it. Sorry, we got some error, but because the boxes wasn't intersecting any, so we just need to drag it along to the ground plane a bit further. So that will be the whole object we're gonna put in the simulation. What we need to do, we just need to bake it, also group it. It's always nice to have. Don't preview it, and then we could select that to export. Select. Once we exported that geometry as a Rhino 3DM model, we go to Simscale, open up a new project. There's a bit step you need to set it up. It's a new project. Win-1 can create. Have to 5 characters, so VARC 7005. So once we created project, you require to import the geometry. So we just need to import the one we just been created. geometry import, because it's relatively really simple geometry, so it won't take too long. Create a simulation. We choose the incompressible as what we try to analyze the wind flow. Let's create the simulations, and then they already selected the geometry for us. And then what we need to do, we need to set the materials as an air. Yep, like rotate it a bit to get a little bit more better to see. We can change the view here. So I sided the box and click OK as the whole thing as the air, and then it needs to have the boundary condition. Let's clear the list. I need to sign it. So we try to analyze the wind come from the top to the bottom. The wind inlet will be that one. We didn't try to select pretty well before selection. Yep, when it was okay, we got a tick. Some still got some input missing. It will have a red circle. So we need to set it up as pressure outlet for the 4 phases in the rest of the thing. So we got the 1 inlet, and the red should be the outlet for the air pressure out. Also we need to set the wall geometry, which could be the ground plane, and also the boxes. So we're gonna assign the geometry as the whole thing, and then click OK. And then we're gonna assign the air, also the whole boxes. Can we select? So we imagine the whole thing inside the boxes is filled with air, and then the velocity inlet could be in the front. Pressure outlet will be in the rest of the faces except for the ground plate. In the wall geometry, it will be the ground plane and then the building itself. Sign, yep. So that is basic setup. So to get the velocity from the x directions, I mean for the uy direction, we could look for your location like Melbourne Rimrose to find out where the predominant wind in your area. I will select Melbourne and then get the roses. So we have the wind rows also could be generated from Ladybug's tool with the EPW file. So it's I separate two data from winter and summer. We maybe use the winter data. It's not because only predominant wind from south to north. It's also the winter winds could be drop down the surface temperature a lot, and because the human feeling of the UTCI stuff is really driven by wind speed. So we kind of use the 626 as the average velocity of winter situations. So we just try to get the 6.26 and then got the inlet done, and then we should able to run the simulation.